For lesson 4.2a, I'm going to attempt to explain how you use what we introduced in class on Monday with right triangle trigonometry and the sine, cosine, tangent functions and the cosecant, secant, and cotangent functions to help you complete My Math Lab homework 4.2a in the online environment. So on Monday we talked about the unit circle and a circle of radius r as they're related to the trigonometric ratios, and you have an orange handout that has all of this on it. And the circle that has a radius r, when we find the sine, cosine, and tangent functions, we can use SOHCAHTOA to help us come up with the ratios that are on your paper. For instance, cosine is x over r, which is adjacent over hypotenuse. And sine is y over r, which is opposite over hypotenuse. And then tangent, which is slightly off the screen, is the ratio opposite over adjacent, and that would be y over x. Now, the difference between a circle of radius r and a circle that is the unit circle is it's called the unit circle because the radius is 1. And when you make the radius 1, that means your cosine becomes x over 1, or just x. Sine becomes y over 1, or just y. Tangent stays y over x. And then the secant, cosecant, and cotangent values, we use the reciprocals of the cosine, sine, and tangent. So using the orange handout that you have with all of this information on it, we want to take a look at a problem like you're going to see in the homework online. And a problem might look something like this. It says, use the figure at the right to find the trigonometric functions at point T. You see, point T is the point that they have labeled as 1/2, comma, square root of 3 over 2. We're going to see later on Friday how this is derived from the special right triangles and gives us points on the unit circle. But for now, we're just going to worry about the ordered pair, which is the ordered pair x comma y. And we're going to use SOHCAHTOA to help us find the cosine, sine, and tangent, which then will allow us to find the secant, cosecant, and cotangent. So this is how it works. We need to learn that the cosine is the x-coordinate of those ordered pairs. Well, the x-coordinate up here is 1/2, so the cosine of t is also going to be 1/2. The sine will be the y-coordinate because this is supposed to be the unit circle. And so at the point P, which is for the angle T, the ordered pair's y-coordinate is square root of 3 over 2, so that would be your sine value. Cosine is the x-coordinate, sine is the y-coordinate. Then tangent is the ratio of the y-coordinate over the x-coordinate, which would be square root of 3 over 2 over 1/2. What happens there is you're actually multiplying the numerator by the reciprocal of the denominator, and in essence, the 2's end up canceling out. If you don't want to rewrite it like this, then you can learn that the denominators, as long as those denominators of those ratios are the same, will just cancel out and will give you the ratio of the numerators, namely square root of 3 over 1, which you can see when we multiply is the same answer, the square root of 3. So for our diagram here, we've got now the cosine value, the sine value, and the tangent value, and then the reciprocals can be found by taking the reciprocal of those three values. So cosine, remember, starts with a C. It's going to partner with the one that starts with an S, which is secant. And the reciprocal of 1/2 is 2 over 1, or just 2. Sine, which starts with the letter S, partners with the one that starts with the letter C, which is cosecant. When we take the reciprocal of the square root of 3 over 2, we have 2 over the square root of 3, which we can't leave like that because we have a radical in the denominator of a fraction, so we rationalize it. We multiply numerator and denominator by square root of 3 over square root of 3, which gives us 2 times the square root of 3 over 3. Then the tangent, we already saw how when we took the ratio, it simplified to the square root of 3. Well, the cotangent would be the reciprocal of that, or 1 over the square root of 3, and once we rationalize it, that becomes the square root of 3 over 3. So, in summary here, we use the coordinates of our ordered pair to help us find the 6 trigonometric ratios. If we can remember cosine is x, sine is y, and tangent is y over x, then the reciprocals are easy to find as long as we partner the right ones together. And remember, opposite letters. Cosine starts with C, it partners with secant, which starts with S. Sine starts with S, it partners with cosecant, which starts with C. And I think tangent and cotangent are a little more obvious to partner together. Let's try another problem. Here is a second problem. This time, the ordered pair is in quadrant 2. The ordered pair here is negative square root of 2 over 2, positive square root of 2 over 2. X comma y. This is just the unrationalized form up above, negative 1 over the square root of 2, comma 1 over the square root of 2. We'll just use what they gave us. So remember, cosine is x. The x-coordinate would be negative square root of 2 over 2. Sine would be y, and we can see that would be the positive square root of 2 over 2. And then for tangent, we take y over x. Square root of 2 over 2 over negative square root of 2 over 2 reduces to negative 1. To get the reciprocals, cosine, of course, partners with secant, so we take the reciprocal, and the reciprocal, once you rationalize it, ends up becoming negative square root of 2. That's the reason I like to show you the original form of this point before it's been rationalized, because you can see if you learn these are equivalent, then taking the reciprocal of negative 1 over the square root of 2 is much easier than taking the reciprocal of negative square root of 2 over 2 and rationalizing. Either way, though, you're going to get the same answer, which is negative square root of 2. Cosecant, same thing. Either take the reciprocal of your sine or use the unrationalized form and take the reciprocal, but you should find that the cosecant becomes the square root of 2. And then the reciprocal of negative 1 over 1, becomes 1 over negative 1, which is still negative 1. And that would help you find the 6 trigonometric ratios. Where we're heading towards is the unit circle. Let me get the unit circle here and put it up so you can see it. And you can find any number of them on the internet. You'll get one in class on Friday, and we'll talk about how it's derived. But for now, you don't have to worry so much about that as using it. And in these cases of these problems, actually using the diagram and the ordered pair they give you. So let me get the unit circle. It's maybe a little hard to read. Here's the unit circle. So you can see here, Each of the positions that we have memorized in degrees and radians have an ordered pair associated with that position. There is some symmetry when you look at the ordered pairs that we'll go over again in class on Friday, but think about it. It's a circle where the radius is 1, and the ordered pairs for the 30 and 60 and 45 positions are coming from your special right triangles. If we learn quadrant 1, these positions, you can use symmetry to get those points in the other quadrants, because the pi over 6 position is symmetric with the 5 pi over 6 position, and the only difference between the quadrant 1 ordered pair and the quadrant 2 ordered pair is that the x coordinate's going to be negative here, and it's positive in quadrant 1. In both quadrant 1 and 2, y's are positive. Well, if you look at the 7 pi over 6 and 11 pi over 6, do you notice that the y coordinate of that ordered pair is negative? In 4, x is still positive, but in 3, both x and y are negative. It's because of the quadrant the multiple of pi over 6 is located in that the signs of those values change. And that's going to be true for the multiples of pi over 3 and pi over 4, and the quadrantal position 0, pi over 2, pi, and 3 pi over 2, because of where you're at. And we'll go over all of this on Friday. To do your assignment, try 4.2a in My Math Lab. Look at the helps, look at this video, and hopefully the combination of all of that will help you be able to complete 4.2a.